Hello, my name is Rayhane from Seoul National University. I'm glad to introduce our paper which has been published in CVPR 2022. The title of our paper is CVF-SID Cyclic Multivariate Function for Self-Supervised Image Denoising by Disentangling Noise from Image. Image denoising is an active research topic in computer vision that aims to remove unwanted noise signals from a given noisy input image and restore a noise-free clean image. The latest denoising methods usually resort to supervised learning on the large-scale synthetic dataset. Nevertheless, recent studies have observed that the denoising models trained on synthetic images do not generalize well on practical examples. We believe that self-supervised learning is an alternative solution to mitigate the mentioned limitation for the real-world sRGB images. Therefore, we propose a novel cyclic multivariate function and utilize it to design our self-supervised image disentangling model for sRGB image denoising. First of all, we note that in general, a noisy image can be expressed as a function of the clean image, signal-dependent noise, and signal-independent noise maps, where signal-dependent noise refers to a combination of a noise-free image and an independent noise map that is spatially invariant. In this paper, we define a novel cyclic multivariate function that outputs multiple variables and can take its output as an input again by combining the output values. By utilizing the attributes of CVF, we aim to train a denoising model in a self-supervised manner. For a given noisy image, we apply our network to generate a clean image, signal-dependent and signal-independent noises. In our design cyclic network, we feed the outputs of our network again to the network to ensure that each output is pure and does not have the information of the other outputs. To train our network, we define a set of loss functions based on a statistical behavior of general noise. First, we define the consistency loss to ensure the combination of initial outputs converges to noisy inputs. Moreover, we construct the identity loss where for a given denoised image, we expect the model to predict the same clean image as the input without any noise terms. We also define similar loss training objectives for images corrupted with pure signal-dependent noise and the predicted signal-independent noise to construct our identity loss. On the other hand, we designed a zero loss to ensure that the network generates zero-valued noises for a clean image, zero-valued image for pure noise, and zero signal-independent noise for input without that noise. Furthermore, inspired by the patch-based local estimation, we first approximate the noise variance from the given image by averaging the variances of m small patches. Accordingly, we define the regularization loss to prevent the estimated noise maps from having zero variances. We also feed some self-supervised augmented images to our network to better estimate the distribution of each noise and improve the performance. And finally, we define the augmentation loss for each of these augmented data. We compare several supervised, unsupervised, and self-supervised denoising methods on SIDD and DND benchmarks. Interestingly, our model trained on a small dataset slightly outperforms the model trained on a large dataset. This observation validates the advantage of our method, which can be directly trained on test sRGB images without requiring raw RGB data or a large number of training samples. Furthermore, we show that our method can be trained in a recursive fashion and outperforms several unsupervised and self-supervised methods on both datasets. Moreover, we show how our method decomposes a given noisy image into the clean image, signal-dependent and signal-independent noises. We train and test our method on a single noisy image, and the result shows that our approach does not require a large-scale training dataset. More experimental results are available in the paper. In conclusion, we propose a cyclic multivariate function and utilize it to design our self-supervised denoising framework, which aims to learn a CNN to disentangle a signal-dependent and signal-independent noises and clean image from a real-world noisy sRGB input. Thank you very much for listening. Our code and the pre-trained models are available at GitHub.